Assalamu alaikum wa rahmatullahi wa barakatuhu. This is Dr. Najam from XII School. First of all, I want to say a warm welcome to all of my intermediate students in your new class. Now, in this new class, you will learn more advanced concepts of the chemistry, especially regarding about element and periodicity and the organic chemistry. Now, initially, we will start with the periodic concepts of periodic table like groups, blocks and periods, and our first topic is about S and P block elements. Now in this lecture we will learn about elements and their periodicity, and also we will discuss about the electronic configuration. Thank you.
So after first year, now you people are in second year, mashallah, without papers. But the conceptual studies are goes on, and you know that chemistry concepts and chemistry topicals are interlinked with each other as per the first year, and now you are in the second year. So in the first unit that is related about the S block and the P block elements, you should know about the actual formation of the periodic table. One second. So there is a periodic table, which is a modern periodic table, and all these elements in this periodic table are divided into different categories. That is groups, that is blocks, and that is periods. So we have 7 periods, we have 18 columns, as you can see in this periodic table, and all these vertical 18 columns further divided into 2 groups, A and B. A group contains 8 columns with the normal elements, and the middle portion, that's your transition metallic, including anthracites and actinides, are with 10 columns. So all these elements are divided into blocks as well, and the block of element depends upon their electronic configuration, which we will inshallah discuss in the next lecture in detail. Now, the way an element reacts particularly determined by the outermost valence electron of an atom. You people know about it. Elements like metals can lose electrons, and elements like non-metals can gain electrons. So the nature of the element is totally dependent upon this concept or this criteria. All the periodic tables are arranged in order of their atomic number according to their modern periodic law, and the vertical columns called groups, horizontal columns are periods, horizontal rows are called periods, and all the elements in the same group have the same number of outer shell electrons. And all the elements of the same period have the same number of electron shell. These all are the basics which you people have learned from earlier classes. So this is exactly the formation of the blocks according to their electronic configuration, which you people have already learned in the first year as well. S block, P block, E block, and F block. S orbital contains 2 electrons in the last, I'm saying 2 orbitals in their capacity. P orbital having 6 electrons in their capacity. D orbital having 10 electrons in their capacity, and the F orbitals having 14 electrons in their capacity. So, periodic table is actually designed on the basis of the significance that every element specify their block according to their last orbital fills. Now, in the electronic configuration, we have practiced that whenever we try to make their sequence according to the rule of rule 1s, 2s, 2p, 3s, 3p, and so on. So we determine that if when we end that particular electronic configuration correctly, so the s or p or d or f orbital is at the end, which represents the actual electron position. Either it's in block S or P or D or F. And one more important thing, it also represents their block and their group as per their electronic configuration. Now, meanwhile, if I understand the elements, so elements are divided into two types. One is a representative element, the second is the transition elements. Representative elements include normal elements, and normal elements contains normal metals, non-metals, and metalloids. So normal metals we get left on the left side. This is the position. This is a group number one. There's a group number two. Group number one is called alkali metals. Group number two is called alkaline earth metals. And other metals are these few metals. And these are the weak metals you can see. Right? And on the staircase, this is staircase. On the staircase, we get metalloids. Metalloids are found in the P block, the right side portion from period group 3 till 8. That's your P block. So metalloids are the elements having metallic and non-metallic properties. So we have one metalloid boron in group number 3, two metalloids, silicon and germanium in the group number 4, and again two metalloids in group number 5, arsenic and antimony, one metalloid that is thorium, and another metalloid that is acetylene in group number 7. So we have 1, 2, 3, 4, 5, 6, 7. And in few books I read about polonium. Polonium is also claimed. Few scientists that it is right. Anyhow, 7 standard metalloids we have. And after metalloid we have non-metals, and non-metals include gases, and one bromine is a liquid non-metal, and carbon, phosphorus, sulfur, selenium, and iodine are solids. So we have non-metals in gaseous form: nitrogen, oxygen, fluorine, chlorine. Right? And at the end, these are the noble gases. Noble gases include helium, neon, argon, protons, xenon, radon, and coke. That's element number 118. So non-metals, including noble gases, are at the right side. Now about the transition metals. Transition metals are found in the middle portion, that's your D block, and at the end of the periodic table in the lanthanide series and actinide series. These all are transition, and transition metals are further divided into two categories. One is outer transition. Outer transition portion is this portion. That. And inner transition, including lanthanides and actinides. These two. Lanthanides, we call it lanthanide because it is starting with anthenium, and actinium we called it because it started from actinium. Okay. So this transition portion is your D block, and this transition portion is your F block in the product. So generally we classify all the elements in such a way that each element in a block represents almost a similar character, right? Just like as block, this portion is as block. These all are metals. This portion is a P block. So there is a metals, non-metals, and metals, metalloid, non-metals, noble gases. So every element is separated according to their properties by mean of electronic configuration. So if we discuss about the electronic configuration in groups, so we can easily determine as Ohm's principle according to the lower orbital will fit first and then later on 1s, 2s, 2p, 3s, 3p. In the next lecture is a detailed lecture regarding about the electronic configuration. So you will understand the basic actual concept about the electronic configuration, and is there any confusion? So you will clarify it, because in the next lecture I will explain detail. I will give you explain detail regarding about the Ohm principle, polyexclusion principle, and Ohm's rule, which will use in this electronic configuration. Now, guys, as block elements. So as I told you about that, gas block elements are on the left side group 1 and group number 2. And we claim the S block elements because they have autonomous electrons subshell S. The same rule, the same criteria is for the P block and is for the D block elements. Outermost electron fill that particular orbital, either S, either P, either D, so that element belongs to. So, as block element properties, they are metals. So, they form stable ionic compounds with non-metals by losing their electrons. Usually, as per element character, they have low magnetic boiling points and have a low density. They are good conductor of electricity because they are metals, and metals are in sea of electrons. Now, only one noble gas is included in as block, and one non-metal, that is hydrogen, included there as block. But due to their non-metal-like nature, properties are totally different. And these two elements are belong to as block. The same reason, their last shell electron is spelled as one. Now, P block elements include, as I told you, group 3 till group number 8, and electrons are being added to the P shell, which includes metals, non-metals, and metallites. But the metals having low metallic character, but they are good in perfect electricity. And about the lead, that is the only element which is radioactive radiations absorbed. So as I described and explained all the components of a P block regarding about light and the product data. P block elements form ionic compounds with non-metals and covalent bonds with other non-metals. It's like gases, oxygen, nitrogen, sulfur, non-metal, carbon, non-metal. and even hydrocarbon, organic chemistry, chemical compounds are all including this. Now, guys, D block elements. D block are called transition or auto transition elements, which includes copper, zinc, iron, silver, etc. Mercury is only liquid metal, which is in this block. They are very good conductor of heat electricity, and they having zero electrons, and even copper is the best conductor of electricity, and gold as well. The finally, F block elements are mm, inner transition, and the top row is called lanthanides, as I told you, because it starts from lanthanide, and the second row is actinide after actinium, and actinides all are radioactive elements. Radioactive elements are those their nucleus are unstable. So this is the block demonstration of the product table, and we will do electronic configuration with their roots, and I will review it with a proper explanation once again. So your work is that you will learn all the rules which we have done in the first year class as well. See you inshallah in the next section.
Now, students, after watching the lecture video, I hope you people will understand about the actual position of the blocks in the periodic table, and also about the periodicity. Now, most important thing about to learn that you people should practice for the electronic configuration as per Auber principle and the Hund's rule, which we have learned in our earlier classes as well. So in the next class, we will learn about specifically period number 3 and group number 1 of the periodic table. Thank you.